All right, chemistry students, here we go. We're going to talk a little bit about density. This is video 1.10, and we are going to introduce density here and really look at some example problems and why density is so important in the scientific world and in everyday life. So here you can see we have our equation. Density equals mass divided by volume. So you need to make sure that you know your measurements there, know what units to use. We want to use grams for mass and make sure that we have milliliters when we are talking about volume. Now, you can also have 1 cubic centimeter as your volume. And really, this is an equation that you need to know, or not an equation, but a conversion. You got to know a conversion. That 1 milliliter is really equivalent to 1 cubic centimeter. And make sure you write that down. So right now, maybe you should pause to write down these quick notes. Okay, now that you have written down those notes, we need to take a look here at what density is. And I have a little discussion here of a short video that I want to show you about density and really why it is important. So let's go ahead and take a look here at density. Whoop, hit the wrong thing here. So let's pause. So here we go, quick video on density.
Jason, and I work at the Canada Science and Technology Museum. Today we're going to be doing an experiment on water density and seeing what happens when two different densities of water mix together. You'll notice I'm standing in front of the Titanic display, but more on that later. For now, let's head to the lab. Every day, vast bodies of water mix together. It could be where rivers meet, at water treatment plants, or where cold ocean currents mix with warm ones. Where rivers meet the ocean, fresh water mixes into salt water. These bodies of water each have different densities due to variation in temperature or salinity. Now we're going to see what happens when we mix water at two different temperatures together. In this side, I have cold tap water. We're going to mark that with blue fruit coloring. In this side, I have hot tap water. We'll mark that with red fruit coloring. I'm going to open the gate, allowing the two temperatures to mix. As you can see, there is a distinct separation between the two temperatures. The less dense red water is on top, and the denser blue water is on the bottom. Just to contrast this, we're going to show you what happens when we mix water that's at the same temperature. With the water at the same temperature, there's no density differences, and the mixing is much more uniform, giving a large swath of purple. So I mentioned before that water density had something to do with the Titanic and other ships. It all has to do with this small symbol here. It's called a Plimsoll line. The Plimsoll line shows the safe limit to which a ship can be loaded. The denser the water, the more cargo a ship can hold. The letters stand for the safe limit to which the ship can be loaded. F for fresh water, T for tropical water, S for summer salt water, and W for winter salt water. For more information on science and technology, come and visit us or check out our website.
So hopefully that video provided a little bit of insight there as to why it is so important, density, why it affects all the ships and a lot of things we ship across the seas. It matters about the density of the water and how much salt is in there, or the salinity of the water. So we have to take that into account. So we want to also look at a few example problems here. So we're going to go ahead and move on and look at a few example problems here that I'd like to work out. So we'll take a look here. Now some of these might look familiar. They're actually from our worksheet. And if you have questions on the worksheet, then these problems are really going to be able to help you here and see the work that's done. So let's take a look here at our first problem. And really what I want to talk about and what we want to cover and really teach you, if you haven't learned already how to set problems up, and that's something I think a lot of students struggle with, is how to set a problem up. I want to teach you the guess method of setting up problems. So it simply looks like this, the guess method here. And it stands for your given, your unknown, the equation, substitute, and then solve. So that's really the setup there of our problems. We want to list what is it that we are given. So in our problem here, 0.446 grams of hydrogen gas fills a 5.0 liter bag. Determine hydrogen's density. Well, what are we given here? Well, I know that I am given grams of hydrogen. Grams of hydrogen, grams, we know from our earlier video that grams is a measurement of mass. So I am given here mass, and that equals 0.446 grams of hydrogen gas. So we will learn that H2 is always going to be a gas, so right now I just want to label it. If you label it just gas, that's fine. So I'm given that. I'm also given liters. I'm given liters here. I know that liters is a measurement of volume. So I have 5.0 liters, and that represents, maybe if you want to just for your own sake, say that that's for a bag so that you know what it is that you have a volume of. Your unknown, what is it asking you to find? Well, it's right here. The density of hydrogen. So my unknown is the density of my hydrogen gas. That's my unknown. Your equation, we know our density equation from the previous slides, that density is mass over volume. And sometimes I'll always help myself and I will put in parentheses, mass is measured in grams, volume is measured in liters. So that's a way there to help yourself in getting these problems done and set up. Now we want to substitute in here. Substitute in, what is my density? Do I know D? No, I don't know D, so that stays as an unknown. Do I know M? And I'm looking here, do I know M? That's what I'm looking for. And yes, I do. It's right up here. That's my M, so I will plug it in. 446 grams. Remember, units, they are so important. Then my volume, do I know my volume? Yes, it is 5.0 liters. And then my solve. My last step then is to solve. So I will plug that into my calculator. 0.446 grams divided by 5.0. And I'm going to end up here with 0.892. Check your units here. Grams divided by liters. Now, your final answer that we want up here. Sig figs. You got to remember your sig figs. Our last digit here, if you look, what did you start with? We started with 2 significant figures here. We started with 3 significant figures here. My answer should only have 2 sig figs. So my answer, I go to my 3rd sig fig is going to round my 2nd sig fig, keeping it the same, 8-9 grams per liter. So that's an introduction there to density and the first problem. We'll have more videos on practice density problems if you need them. Otherwise, make sure you keep up on the notes.